in that whole area, to providing sufficient funding to keep things moving.
Well, a couple of points made here that could be useful on project control and the funding authorization. Bruce mentioned that based on a meaningful funding profile, we could pick up people from the Liquid Metal Engineering Center in Santa Susana and bring them up here, and likewise people from Westinghouse Waltz Mill who were designers on some of the systems, and bring them out to the reactor plant. So in fact they could see and live with the design that they had developed. There's another aspect to that that Dave touched on, and that is having a recognizable, meaningful funding profile lets you keep a project on schedule through the procurement of long lead components. For example, a Byron Jackson pump, you have to negotiate a contract with Byron Jackson for a primary pump that's going to extend for more than a year. Intermediate heat exchangers the same way. The supplier has to have a contract. The contract's extending for more than a year. Therefore, you'll have to have the funding authorized and in-house in order to let the contract for those long lead components, and if you delay because you don't have the funding, then you'll slip the project schedule. But let's go on to the next point, which we've alluded to, but now we want to talk to in more detail, and that is system completion, turnover, and acceptance testing. And again, let's start with the client's viewpoint.
Well, as been alluded to here before, a discipline program for the turnover in plant systems and from the construction contractor to Hedl, followed by extensive formalized acceptance testing of the systems to assure that design requirements have been met. Recall that the project was set up with Westinghouse Advanced Reactor Division as the reactor designer, with Bechtel as the architect, engineer, and construction manager, and with Hedl established by AEC specifically for the purpose of operating and utilizing FFTF. So the turnover basis involved moving from the constructor to the operating organization. The constructor had the responsibility of doing his own construction testing to make sure that the systems met his design requirements. The Hedl operating organization, having then taken over the system, turned over the system, accepted it from Bechtel, conducted the operational testing, as Bruce has alluded to make sure that the systems met their design requirements for the overall plant. That was the overall system, which worked very well in this project.
Okay, this is kind of getting into my area now. I'm alluding to this and alluding to that, and you bet. A major feedback I would like to make is that the planning for the turnover of parts of the plant, piecemeal parts of the plant, was far more, it was recognized late and required an awful lot of unplanned work by the constructor, Bechtel, and ourselves to get the pieces of turnover packages defined and ready to turn over. It affected the drawings, it affected the field construction, and it was extensive. So this was a major setback to the project that we had to throw at this, we had to put in place as turnover package definition, package by package by package, hundreds of them for the plant. They all had to be finished from the construction standpoint, and we had to have drawings ready to go for the test people. We also made a requirement that safety-related equipment be shown on the drawings in a red line fashion, that operations can know whether they're working with a safety-related system or not. And we had to go through the drawings and through the plant and label systems and the equipment as being safety-related. We also had to identify what pieces of the plant had been turned over to Hiddle by the construction contractor. Therefore, we had to put labels throughout the whole plant as to what was turned over, what was not, and gradually change those labels to show that this and that had been turned over. Last comment here on that. The pre-test walkthrough by our test engineers and the construction crowd were vital. Everybody had to know what pieces were included in the test and had to be all turned over from construction. So we had walkthroughs, we had drawing emphasis. The turnover program was intense. We came across some difficulties that the usual construction drawings do not show all of the control circuits, the alarm circuits, the low voltage circuits. They show the high voltage circuits, but operators and electricians and maintenance people need to know that there's a hot circuit in there somewhere that doesn't show in the drawing. So we had to ask them to be sure to include in the turnover drawings the low voltage circuits as well as the high voltage circuits to keep people from being electrocuted. The startup program required a lot of skills on the part of the individuals. By that I mean the operators, the crafts, as well as the test engineers. The individuals had to be technically strong, skilled, and especially in field work. You couldn't take a computer engineer and put him into a field work and get the job done the way you want it to be done. So they got to be skilled in the field. They have to be very, very resourceful, and they have to be made of heroics and dedication and things of that sort, because we asked a lot of them. We also got a project ruling early that we would use the bargaining unit unionized maintenance crafts. That was their work. But we said the operating staff will be non-unionized, non-bargaining. And that program held for the life of the project. Operators were recruited from the Nuclear Navy program very quickly. We were not hamstrung by the requirements that if they were bargaining, you'd have to have these people be considered first. So we were able to build up a staff of operators because of that ruling. And that was a helpful tool. People became very frustrated during the acceptance testing, especially with weekend work and third shift work. We had plan of the day meetings every day to try to outline the work tasks of the day, that we had staffing in place. The individuals were reluctant to carry the full workload of the weekends. We had to, if they hit a fault condition, they would sometimes abandon the task for the day and go home. We finally had to put a management person on each shift to look at the staffing of the test and know before people gave up and went home that we could not bring others out there to solve the problem and hold the schedule for the day. So we did a lot of resourceful rescheduling on the floor. And these particular individuals that were the shift engineers, test engineers, the leaders there, provided a lot of help by getting the focus on at the difficult times. I'd like to hear some other thoughts on this from others, but those are my highlights. You got it, Alan?
Well, yeah, I think if had any sense, I'd pass on this one because I really was not involved in the system turnover. I mean, I feel like I've been drinking out of a fire hose here listening to Bruce talk. It's fascinating. Clearly, from a safety standpoint, as Bruce pointed out, there are some systems that are safety grade, and obviously those we followed very carefully. But I think, Dave, you probably have a lot more to talk about this as part of your, I'll come back in later. I wasn't directly involved in this part of it.
Yes, as I said earlier, I came in as a test engineer, so I spent quite a bit of time in the field as a test engineer for FFTF. Bruce alluded to the original turnover from construction. Much of that had been accomplished by the time I got here. There was actually a second turnover from test engineering to operations, which occurred as part of the formalized acceptance test program. Now, the formalized acceptance test program run by the FFTF project and Heddle was very thought out, was very detailed. By the time we got done in 1982 and ended up going to our first operating cycle, we had completed, I think it was a total of 166 tests, independent tests, as part of the acceptance test program. It had been broken into 5 different phases, and in those 5 phases, within those 5 phases, there were test time frames identified that would allow you to run pieces of or complete tests during certain time frames, because people needed to know, well, can I run these 3 tests at the same time without interfering with each other, or are they going to interfere with each other and therefore can't be run at that time? So a lot of planning went into that, and a lot of things were thought out that tried to avoid any of those kinds of things. The operations group at FFTF then would, Bruce alluded to the plan of the day, one of their responsibilities was to look at what was planned activity for that day, both maintenance and testing and other things, and to make sure that nothing interfered with each other. So they actually released the work to happen. And in doing that, they made sure that, well, this particular piece of work isn't going to take out another piece of equipment that you're trying to run, and this piece of, in this work, and that type of thing. So they had to be very, very familiar with how the plant went together, what the interfaces were, that type of thing. The test acceptance program, the details of how to run a test, how to write up a test, how to write up a test procedure, all those kinds of things were very, very thought out. And we had engineering instructions or test instructions that led us through the development of those kinds of tests, how you documented what you were doing in the field, whether you had to stop and get immediate response or get immediate correction if something went wrong, or whether you could document that, continue on with the tests, and come back and later fix it. So a very detailed planning process, lots of instructions out there to tell you how to do that. We had people that went through a little bit of extra training to become what was called a chief test engineer, who had responsibility for the overall test. We also had field engineers or field test engineers and shift test engineers if a test was being run on a 24-hour clock basis. So all of those kinds of things went together to try to run those tests on an efficient basis. Having had experience in running some of the tests, some of the best ones that were run were those that ended up being on critical path, because you got all kinds of assistance, sometimes a little more than what you wanted, in order to complete that test. But if you needed some help, if you needed maintenance, if you needed ops, if you were on critical path, you always got them. And it was no problem with that. That's pretty much it, I guess, as I would, we talked a little bit about the turnover after testing. Test engineering took and ran the acceptance tests, got everything through, documented the test results, got approval of everything. And then one of the last steps in that process was to make turnover to operations. Said, okay, this system now has been tested, it meets all the requirements, it's been calibrated, everything runs right. I agree now that this piece of equipment or this system is ready for continuous operation. And there was a form that test engineering then would go through and sign and say, okay, everything's done, everything's testing right, everything looks right, and then we take that to operations, and operations then would look that over and agree, they would sign, and then we would formally turn that system over to operations for routine and continuous operation. And so that's how we in test engineering then closed the books on what we were doing and continued on with operation.
He's talking about a test certification. I'll be discussing that some more later. Test certification, really important.
I might make one point. I think Bruce and Dave are being far too modest here, and so let me say why. During construction, the construction manager and the architect engineer is the dominant force out there. Okay, they have an energy, a scale, and a momentum that are all their own. On the other hand, you can't allow construction to go on and on forever. Sooner or later, you'll have to have an operating reactor plant. And they're referring to that transition. And Bruce mentions the intensity. There was probably nothing more intense than the Plan of the Day meetings that Bruce ran, okay? If he doesn't remember it clearly, then some of the rest of us do remember it clearly. Bruce was the driving force that took the plant from a construction plant to an operating plant, and Dave was part of that too. And the turnover, the testing of the reactor plant system by system, and the turnover of those systems, I think was a key element to maintaining control of the cost and turning it from a construction plant to an